And for continuation of our mathematical induction problems, we have example 2. Prove by MI that 2 raised to the power n is greater than or equal to n squared is true for positive integers n greater than or equal to 4. So for step 1, we need to prove our base case, which is n equal 4. So prove true for our base case n equals 4. So we have 2 raised to the 4th power is greater than or equal to 4 raised to the 2. And that is just 16 is greater than or equal to 16, which implies that for our base case n equal 4, it is true. So now for step 2, we have our assumption, and we're going to assume true for n equals k, where we have k's in our set of integers greater than or equal to 4. So we have 2k is greater than or equal to k raised to the 2. So now for step 3, we need to prove true for n equals k plus 1. So we're going to start with our left side of 2k plus 1, and that's equivalent to 2k times 2. But our assumption is 2k is greater than or equal to k squared. So we can just say 2k plus 1 is greater than or equal to k squared times 2. So there we have 2k, and we can just break this up as k squared plus k squared plus 2k minus 2k plus 1 minus 1. And we haven't changed anything right there. We just add some terms and minus some terms. So now we have k squared plus 2k plus 1 plus k squared minus 2k minus 1. And factoring our k squared plus 2k plus 1, we have k plus 1 squared plus k squared minus 2k plus 1. And if we notice that from our assumption we have k squared is greater than or equal to, we have 2k is greater than or equal to k squared. So now if that is true, then 2k is greater than k squared minus 2k plus 1. So now we have so now we have for n greater than or equal to 4, we have 2k plus 1 is greater than or equal to k plus 1 squared.